day, everyone. I am Cadet Racing Brian from NT3 Alpha, and I'll be discussing about the GMDSS, or the Global Maritime Distress Signaling System. GMDSS is very important for us seafarers, or um, it will help us to um, transmit signals, especially when we are under distress. It helps the vessel to receive and transmits message, and it keeps the communication alive in a vessel to vessel, or ship to shore communication, such as the RCC to a vessel as well. So first off, for the communication through NAVTEX. So NAVTEX is an international automated have a frequency of 518 kilohertz direct printing service for delivery of navigational and meteorological warnings and forecasts that is urgent in the maritime safety information for ships. So NAVTEX stations repeats all the valid messages in each transmissions, provided that it can be transmitted within 10 minutes time. So the NAVTEX receiver on board stores the successfully received messages for 72 hours, and in next transmission, if vessel is still in the range, it will only receive and print any new messages. So that would be all for our NAVTEX. Now for our AIS. So AIS means Automatic Identification System. So AIS uses a transponder or transceiver, a GPS and VHF antenna. So AIS improves maritime safety aids in collision as well, and helps to identify ships that are not in sight. AIS as well transmit the ship's data to other vessels capable of receiving the AIS. So here we have the AIS. So AIS operates principally on two dedicated frequency or VHF channels. So AIS-1 works on 161.975 megahertz. That is channel 87B, 87 Bravo, used for simplex, for ship-to-ship receiving of data, and AIS-2 having 162.025 megahertz, channel 88 Bravo. So that is used for duplex, for the ship-to-shore transmitting of data. So next we have our VHF. So here, the importance of VHF, you have instant communication with other boats, marinas, bridges, and as well as USCG, or the US Coast Guard. So in this equipment, VHF radio is very crucial since from its channels, channel 13, 16, 19, 22, and 70. So commercial shipping communicates its operation and confirms passage on channel 13. So the FCC, or Federal Communications Commission, has assigned channel 16 with a 156.8 megahertz as the country's distress, safety, and calling frequency. So what is VHF? So what is the frequency of VHF? So the frequency of VHF runs about 30 megahertz up unto 300 megahertz, 30 megahertz to 300 megahertz. So how does it operate step by step? So right now we have here our VHF. So currently turn it on. So right now it's on channel 16. So we can increase the volume if we want to louden it up. And this is the indication of we are transmitting and receiving. So for example, we are trying to send a message. We will the light of the transmit turns on, and if someone is trying to relay a message to us, the receive light will be on. So this is the page. So this is the this is the squelch. So if it's like clutter in the radar, so if you want to hear things more clearly, you minus the squelch. So this is the dual watch. So you can change channel. For example, you're going to channel 14, for instance. Just click enter. You go to dual watch. So in dual watch, you are hearing you're receiving from channel 14 as well as on channel 16. So for example, channel and the square. So that's for the VHF. This is the VHF DSC. So it has functions that will indicate your position, the stations that you have, the time based on UTC, and you can test as well print, and the options wherein you have your identification number such as the MMSI number, the ship's MMSI number, and the group. So now we are going to discuss next is the MFHF. So for the VHF, so under normal radio conditions, the expected radio communication range of VHF will normally be expected to be between 20 to 30 nautical miles. That would be all for our VHF. Okay. So next, we will have our MFHF. Now, for our MFHF, we have the importance of MFHF as radios having a greater range thanks to their ability to refract their signals through the atmosphere. It gives us long distance ship-to-ship or ship-to-shore communication. So this acts like a VHF, but it has a wider range of communication since it has a medium frequency and high frequency band. It can transmit and delivers messages through a longer distance than a VHF. So that's why it is very crucial. So in terms of the frequency, for the VHF, we have 20 to 30 nautical mile radius due to having a 30 to 300 megahertz. But in the medium frequency, we have 300 kilohertz up unto 3 megahertz. And MF or HF rather, high frequency, we have the 3 megahertz to 30 megahertz. So this is how you operate the MFHF. So this is the MFHF. We are turning it on. So we are under 2182 megahertz. So this acts like a VHF wherein you can receive the RX and transmit as well. And if you are on the same frequency, you can hear each other's messages. You can also have a gain here and the volume like our VHF. Yan. And when we transmit the message, we just click this and turn it on. So we can see that we are transmitting the message. And when someone is trying to give us the message with the same frequency band, we will see the receiving side here. The lights will automatically turn on. So that would be all for our MFHF. So MFHF is different from VHF since it has a longer range than the VHF. Ayan. So in MF, the medium frequency, it is used as a system to communicate between large vessels and coastal radio stations. So the range is limited to approximately 300 nautical miles. Since virtually all coastal radio stations worldwide cover MF, medium frequency. So here, it is just approximate since we can it is very hard for us to pinpoint how long is the exact distance of those radio waves could travel. So in the MF, we can approximate 300 nautical miles. So next would be having the INMARSAT-C. So the INMARSAT-C is one of the top supplier of Gmdss approved satellite, since it can reach up to 82 degrees north and 82 degrees south of both poles. So it has really a wide range since it uses a satellite in order to deliver in sending messages all around those the scope of its perimeter. So since the introduction of the Gmdss in 1999, INMARSAT-C service has been already giving safety for seafarers by receiving and transmitting crucial ship-to-shore and shore-to-ship distress notifications. So the frequency of our INMARSAT-C is like what I've said. It covers a ranges of 82 degrees to north to 82 degrees south. So the frequency for transmitting is 1626 decimal 5 megahertz up unto 1645 decimal 5 megahertz, and it has a different frequency for receiving. So for receiving, we have 1530 megahertz up until 1545 megahertz. So how do you operate INMARSAT-C step by step? So this is our INMARSAT-C. So like this, we have a format in sending messages from the latitudes of 82 degrees to 82 south to 82 degrees north. So that is the limit of our INMARSAT, and those on the polar region is already out of range. So in our INMARSAT-C, you can see the guidelines. You indicate your you identify yourself first, the nature of your message, then your message, your position as well, your MMSI number, and the time of when you are transmitting the message, the captain's name, the call sign of the vessel, and as well as the MMSI number again. So that would be for our INMARSAT-C. And here we have the Gmdss printer. Just like turn it on. There you go. So we can print the text that we transmit through the INMARSAT-C on the Gmdss printer for documentation or proof of whatever situation arises. So that would be all for our INMARSAT-C, and I will further discuss it through our brief discussion on our radio telephony and as well as our INMARSAT-C. So regardless of the long latitude, as I've said, it can occupy 82 degrees. It can range up to 82 degrees north to 82 degrees south. So higher latitudes like the polar regions are not under the coverage of our INMARSAT-C. So in different areas, sea areas, it is classified by Area 1, Area 2, Area 3. So this set of equipments is very crucial on board since different areas requires a longer range of transmitting messages, longer distances. Since Area 1 ranges up from 20 nautical miles to 0 nautical miles up to 50 nautical miles. So within that area, the best equipment that we can use is through the radio telephony, which is the VHF DSC. So next we have the Area 2. So that has a wider area, so that the range is under 50 to 400 nautical miles. So as we can say earlier, in the MFHF, it can go roughly around 300 nautical miles. So within that being said, the equipments that we could use under those range is the VHF and the MFHF. Since the VHF can go roughly around the ranges of 20 to 30 nautical miles only. So that also depends on the weather conditions and external factors that could affect the communication or the transmission of message. So for Area 3, that is roughly around 70 degrees south up until 70 degrees north. So with that being said, it is still under the INMARSAT. So one of the great equipment that we could use is the INMARSAT, as well as the MFHF and the VHF, since they vary in ranges, and the longer the range, the different equipment should be used in order to deliver messages in distance that could be capable on such areas. And for those that exceeds from that 70 degree north to 70 degree south perimeter, that area, that is considered as Area 4. So that is above those above 70 and above 70 degree north and below 70 degree south. So in that cases, we could use the HF and the MF as well as the VHF for transmitting messages and receiving messages, so that communication is still possible on those areas, those polar areas. So that would be all for my for this video. I hope you learned something. Thank you and have a great day.